Ashish sir, very good morning, sir.
Good morning, sir. Very
Good morning,
good
sir.
morning, sir.
So, a very good morning to all dear participants over here. On the behalf of Sagar Group of Institution, we welcome all participants of 1 week Sales Summer School. Today is the last day of our Sales Summer School. So, I welcome Mr. Ashish Srivastava, trainer of Ansys Workbench. We welcome in the behalf of the Sales Group, sir. Thank you, sir, for coming here. And I hand over the screen to the Ashish Srivastava, sir. Kindly proceed to the our session.
Okay. Thank you very much, Neeraj sir. Today our last session of this SACE summer school. So today we will be perform live computational fluid dynamic analysis on elbow pipe, which is used in power plant and other hydraulic industries. Okay, so click on Ansys Workbench. When you click on Ansys Workbench, then you find out here fluid flow fluent, fluid flow fluent. So click on fluid flow fluent. So open this window. Okay, open this window. Then go to the geometry. Then click and right click your cursor. Then here option indicate the import your geometry. Then you find your geometry in browse. Then select your geometry. Then import here. Then click on mesh. When you click on mesh, then we can see that the window here. When you click on mesh, then this window we can see here our geometry. This our geometry comes in CFD as a top end of this software, and this CFD enterprise is clearly shown in meshing. Then here we can see that our geometry, this is the L pipe. Okay, so we find out the what effect of the water. Here we take the fluid as from a water and pipe. So water comes inside the pipeline. What effect to produce like that? The pressure, kinetic viscosity, and streamline velocity, etc. So we find out the different types of parameter which is related to the fluid. Okay. So first of all, we select here, go to the mesh, then right click, and then generate this meshing. So this mesh will be generated. So this is very fine meshing. If you want to check how many nodes and how many elements is generating in this meshing, so click on the statistics. So we find out 18,769 nodes and 86,417 elements value. So this is very fine meshing produced. So this analysis is very complicated analysis. We know that about a CFD, okay, compared to the all analysis, because this is a more time taking process analysis which is related to the uh, directly fluid contact. Okay, so now first of all we go to the name selection. Now our next step, go to the name selection. So we select the name selection, go to the inlet. So this pipe, select this area, then right click your cursor, then go to the name selection process. So here put up the name selection. Suppose the here click, then create name selection. So this one will be created name selection. So create here name selection the inlet. Okay. Then another outlet. This is the outlet of the pipe. Okay. So this is the another name selection outlet of the pipe. Okay. Then go to the wall. This is the wall of elbow pipe. So three name selection we have selected here, like that, the inlet of pipe, outlet of pipe, and wall of pipe. So this phase is completed. When you done this phase is completed, then go to the up first window. Then go to the first window, then click on the mesh, find out the option is update. So click on the option is update. This is necessary to uh, run your model. If you don't update here, your model cannot be run in Ansys Fluent in previous. Okay, so we want to update this mesh, then click on the setup. So when you click on the setup, then go to the solution. When you click on the setup file, now we can see here, again select another slide. Okay, when you click on the setup, so we see clearly here, this is pipe. This form of pipe come into the CFD solver. Now we can see clearly this file come into the CFD solver. So this is all command promote is with help of the software is clearly shown preparing mesh for the display on model. We can see is, here the fine mesh here generated in a display model which comes in a fluid CFD. Okay, so go to the journal. So our first step, go to the setup. So click on the journal. When you click on the journal, so we find out types of solver. Which types of solver you want to select here? Steady and transient. So first of all, we calculated the steady and transient. This study depend upon the laminar flow. Okay, so calculation mathematically flow type calculation, laminar and turbulent. If your study is a steady flow, so select the pressure based, and velocity formulations select absolute, and time taking process take the steady, and take the gravity. Which direction gravity you want to? X direction we take the gravity is minus 9.81. Okay, then click on model. This is the very important numbers of models here indicate like that the multi-phase model, energy, all mod will be off. When you click on the firstly model, this is required which types of analysis you want to perform. This is analysis is known as the discrete phase model or volume of fluid, VOF. Okay, so we click on the energy on. When you click on energy, when you click on the energy on, so here energy equations, when you select it and click on the dial box, then apply the okay. Okay, so now why we are selecting the discrete phase model? Because discrete phase model, when you click on the discrete phase model, because here find out the discrete phase model like that the interaction with the continuous phase, update DPM, source every flow interaction, time of the DPM phase, tracking, numbers of steps, 25,000 numbers of step here we considered. Numbers of length factor take the 5. Click on the physical model. Which types of you have here the physical model? We have select the pressure gradient model and erosion related model. So we have selected both model also. Okay, then all here accuracy control limits tolerance selected, and tracking scheme higher order selected, and parallel we take this method is hybrid method we select. Okay, then click on the okay. So this is the two model energy on. Then we take the DPM analysis, discrete space model. Then go to